In this video tutorial, we are going to discuss some questions that are related to Learning Unit 2, Part 1 to 3 that has been uploaded before. So in this tutorial, these are the subtopics that will be covered. So the first one is calculating formal charge. So if you encounter some resonance structure, how do you calculate the formal charge? And then when we have already calculated the formal charge, we need to choose which is the best resonance structure. And then if we have a series of compounds, so how do we discuss the trends in the lattice energy? And then in terms of molecular compound, okay, so how do we draw the Lewis structure and determine their molecular geometry? And the last subtopic is on the orbital hybridization. Okay, so the first question here addressing the formal charge calculation and also how do we determine the best resonance structure of all these structures, yeah? Okay, if we look at the question here, the following are three possible Lewis structure for thiocyanate ion NCS-1. So this is structure A, and then the second one is structure B, and the third one is structure C. So the question asks, first, calculate the formal charge of the atoms in each structure, and based on the formal charge that has been calculated, so which Lewis structure is the preferred one? Okay, so we will discuss how can you answer this type of question. Okay, for question number 1, how can we solve and how can we calculate the formal charge of every atom in every structure? As you all know, the formula for formal charge is electron valence of the atom minus En, or the unshared electron or the lone pair electron, minus Eb. Eb refers to electrons that involve in the bonding divided by 2. Okay, let's take a look at structure A. So Fc4N here is electron valence for nitrogen is 5, and then electron non-shared electron or the non-bonding electron or the lone pair electron, so we can calculate here 1, 2, 3, 4, 5, 6. And then if we look at the electron bonded, so this bond here, it has 2 electrons, so 2 divided by 2 equals to minus 1 minus 1, it is minus 2. So in this case, nitrogen is minus 2. Okay, now we have a formal charge for carbon. So we all know that carbon has electron valence of 4 minus unshared 0 minus the bonding is 8 minus divided by 2. So 4 minus 0, 4 minus 4 is 0. Okay, now we look at the Fc4S. So S electron valence for S is 6 minus lone pair 1, 2, 2 minus the bonded 6 divided by 2. So it is 4 minus 3 equals to 1. Okay, this is 0 and this is plus 1. Okay, now let's take a look at structure B. For structure B, okay, first we calculate the formal charge for nitrogen, which is the electron valence is 5 minus unshared is 4 minus the bonded is 4 divided by 2. So 1 minus 2 is minus 1. And now we have Fc for carbon. So carbon here is 4 minus 0 minus 8 divided by 2. So it is 0. And now we look at Fc for sulfur. So sulfur has 6 electron valence minus 4 unshared electron minus 4 bonded divided by 2. So it is 2 minus 2 equals to 0. So in this case, this nitrogen is minus 1, 0 and 0. You see, we also need to calculate all the formal charge for every atom. So Fc for nitrogen is 5 minus 2 here minus 6 divided by 2. So it is 3 minus 3 equals to 0. And then Fc for carbon is 4 minus 0 minus 8 divided by 2, which is 0. And then Fc for sulfur, it is 6 minus, we have 6 lone pair electron here. And then 6 minus 2 divided by 2. So it is 0 minus 1 equals to minus 1. Okay, in this case, it is 0, 0 and minus 1. So, which one is the best structure? So, when we look at this three structure, it should be 0, 0, 0, the best. But here we do not have 0, 0, 0. So, of course, structure A is out. Okay, now we look at 0, 0 and minus 1. So, this minus 1 is for nitrogen and this minus 1 is for sulfur. Okay, in the rule of formal charge, the minus should reside at the most electronegative atom. So in this case, nitrogen is more electronegative than sulfur. So that's why structure B is the most preferred structure for thiocyanate ion. Okay, another one is question number 2. So explain the following trend in lattice energy. You have learned about lattice energy in learning unit 2, part 2, if I'm not mistaken, which involve the ionic bonds. Yeah? So how do we calculate a lattice energy and what are the factors that influence the lattice energy? As you all know, there are two factors that influence the lattice energy. First, the charge of the atom, the charge of the ion, and then the number 2 is the size of the atom. Okay, now let's take a look on how we can solve this problem. Okay, let's look at the first atom here. So why calcium fluoride has higher lattice energy compared to barium fluoride? Okay, fluoride is the same, but we have difference between calcium and barium. So in this case, both calcium and barium has 2+ charge. Okay, so the charge factor can now be omitted. Okay, now we have another factor, which is the size. Okay, if we look at the periodic table, barium 2+ has larger size compared to calcium 2 plus. In this case, since calcium 2 plus is a smaller ion compared to barium 2 plus, therefore calcium fluoride has higher lattice energy. Okay, now let's take a look at these three compounds. Okay, so sodium, rubidium and cesium, they are all from group 1. So since they are all from group 1, their charge is positive 1, positive 1 and positive 1. Therefore, charge factor can be omitted, and now we only need to look at the size of the ion. Okay, now in this case, sodium plus, rubidium plus and cesium plus. Okay, in terms of the size, sodium plus is the smallest, followed by rubidium, and cesium has the largest size. Okay, in this case, the compound with the smaller ion is the highest in lattice energy. For question 3, we need to draw the Lewis structure for each of the following molecules and predict their molecular geometry. So the first molecule is CH3+. Okay, the first step that we need to do is calculating the valence electron for all the atoms. So in this case, carbon has 4 valence electron, hydrogen has 1, but we have 3 hydrogen here, so times 3, so it becomes 3. And then we have 1 positive charge plus 1 positive charge, meaning the sum of the electron we need to minus with 1, so the total number of electron is 6. You know that there are 3 hydrogen. Okay, so in this 3 hydrogen, every hydrogen contribute 1 electron, and carbon contribute 1 electron, and 1 more electron of the carbon has been neutralized by the positive charge. So we get this Lewis structure, and the molecular geometry is trigonal planar. Then we have the second molecule, which is BrF3. So we need to calculate the total number of electrons for all the atoms. So Br has 7 electrons, and fluorine has 7 electrons. And since we have 3 fluorine, so it is times 3, 21. So total number is 28 electrons. So when we have 28 electrons, what we can do is we have Br with 3 fluorine. Okay, now we know that fluorine has 7 electrons. Okay, so this 1 electron coming from the fluorine. Okay, bromine. So bromine should have 7 electrons. So in this case we have 1, 2, 3. So another 5, another 2 here, and another 2 here. Okay, so the molecular geometry is T shape. Okay, for question 4, we need to determine the hybridization of the central atom in the following compound. So the first compound is HCN. We know that this is the Lewis structure of HCN. Okay, so there are 2 electron domains around the carbon atom. Okay, these are the electron domain. There are 2 electron domains. So this central carbon is having sp hybridization because there are 2 electron domains, one is S, one is P. Okay, now let's take a look at the second molecule, which is silicon tetrachloride. So in silicon tetrachloride, so the Lewis structure of this silicon is like this. Okay, since it should be, the molecular geometry is tetrahedral. Okay, so since it is tetrahedral and it has 4 electron domain. 4 electron domain. So the geometry is, the hybridization is sp3 hybridization. Okay, that's all for the tutorial video. And you can try the practice exercise given in the handout. Thank you.